Welcome to the Bodhi Academy. In today's video, we will continue the class 7 math chapter, that is integers. So in the last video, we have seen what are integers and some of the basic exercises we have solved in the first video. So in today's video, we will learn about the properties of addition and subtraction of integers. So these properties include closure under addition, closure under subtraction, commutative property, associative property and additive identity. So all these 5 properties we will learn in this video. So the chapter name is integers. And today we will learn the properties of addition and subtraction of integers. So the first property in this is the closure under addition. So what this closure under addition property means is that if suppose there are two integers, that is a and b. So for any two integers, if the sum of these integers, that is a plus b, is suppose for any two integers a and b, the sum of the two integers, that is a plus b, is an integer, then we say that integers are closed under addition. So if we take any two integers and if their sum is an integer, so the answer that we get is also an integer, then we say that integers are closed under addition. So let us take some examples. Let us see first one. 17 plus 23. So the answer will be 40. Now is 40 an integer? Yes, it is an integer. Then let us take another example. Minus 10 plus 3. So what will be the answer? Minus 7. Is minus 7 an integer? Yes. Then another example. 19 plus minus 25. So for this the answer will be minus 6, which is also an integer. Another example is 27 plus minus 27. So here what will happen? This plus minus will become minus. So 27 minus 27 will be 0. So is 0 an integer? Yes, it is an integer. Another example. Minus 20 plus 0. So here this will also give us answer as minus 20, which is also an integer. So here we see that for any two integers, so for any two integers, the sum of their sum of any two integers, that is the a plus b of the two integers, is always an integer. That is why we say that integers are closed under addition. Closed under addition. Understood? Then the next one is, the next property is closure under subtraction. So here what it means is that for any two integers a and b, if the subtraction of these two integers, that is a minus b, if this answer is an integer, then we say that integers are closed under subtraction. So let us see some examples for this property. So suppose our a is 7, then minus of b is 9. So what will this be? 7 minus 9. It will be minus 2. Is minus 2 an integer? Yes, it is an integer. Then another example, we have minus 21 minus, we have to subtract a and b, a minus b we are doing, so minus 10. Here what will happen? Minus 21 minus minus plus, it will become plus 10, that is minus 11. So is minus 11 an integer? Yes, it is an integer. Then third example, we have minus 18 minus minus 18. So here what will happen? Minus 18, this minus minus will become plus 18. So minus 18 plus 18 will get cancelled and we will get as answer as 0. So is 0 an integer? It is an integer. Then another example is minus 29 minus 0. Here also we will get answer as minus 29, which is an integer. So here in this case we have seen that for any integers a and b, the difference of these integers, that is a minus b, the answer of a minus b is always an integer. So we say that integers are closed under subtraction. Under subtraction. So this is our second property. Then the third property that we have is, so the third property is commutative property. Commutative property. So what this property means is that we know for whole numbers, suppose I give an example 3 plus 5. So for whole numbers, what are whole numbers? Starting from 0, 1, 2, 3, 4 and all the positive numbers. The whole numbers do not have any negative numbers. So for whole numbers, if I take example of an whole number, 3 plus 5 is equal to 5 plus 3 is equal to 8. Correct? So we know that whole numbers can be added in any way. Another example is 1 plus 4 is equal to 4 plus 1 is equal to 5. Right? We can take any number in any order and the answer will be the same. Now let us see if this is true for integers. So let us take an example, that is if we take the first example, if we take minus 8 plus minus 9, what will be it equal to? It will be minus 8 and minus 9. Sorry, it will be minus 8 minus 9, which will give us the answer as minus 17. And if we take it in the other order, it will be minus 9 plus minus 8, and here also it will be minus 9 plus minus will get changed into minus, so we will get minus 17 again. So we can say that minus 8 plus minus 9 is equal to minus 9 plus minus 8. Correct? Then another example that we can take is minus 45 plus 0. So what this will give us? The answer will be minus 45, and if we take 0 plus minus 45, here also the answer will be minus 45 only. So we can say that minus 45 plus 0 is equal to 0 plus minus 45. Okay, then the third example we have is 5 plus minus 8 is equal to minus 3, then minus 8 plus 5 will also be minus 3. So in all these examples we can see that if we add these integers in any order, the answer always comes the same. So thus we say that addition is commutative for integers. So we say that addition is commutative for integers, since these integers can be added in any order. So now for whole numbers we know that subtraction is not commutative, because 10 minus 5 we can do, it is answer will be 5, but 5 minus 10 we cannot do, because in whole numbers negative numbers do not exist. So subtraction of whole numbers is not possible, is not commutative. So subtraction of whole numbers is not commutative. Now let us see if subtraction of integers is commutative or not. So let us take some examples. So the first one is 10 and 6. 10 and 6. So we have 10 minus 6, which will give us 4. And then 6 minus 10 will be minus 4. So here 10 minus 6 is not equal to 6 minus 10. 6 minus 10. Then another example that we can take is minus 9 and 5. So here if we take minus 9 minus 5, it will be minus 14. Whereas if we take it in the other way, 5 minus 9, then here it will become minus, it will become plus, and then the answer will be 14. So here also we can see minus 14 and 14 are two different integers. That is why minus 9 minus 5 is not equal to 5 minus 9. Let us take another example, that is 28 minus 0. So So here the answer will be 28. Whereas if we take 0 minus 28, we will get answer as minus 28. So here also 28 minus 0 is not equal to 0 minus 28. Thus we say that subtraction of integers is not commutative. Then the next property that we will see is associative property. Let us see what is associative property. So associative property of integers. Now what this property says is that if there are any three integers a, b and c, then a plus b plus c is equal to a plus b plus c. So let us see some examples and see if this property is true for integers. So we have minus 3 plus 1 plus minus 7. So these are our a, b and c. Now let us solve this. It will be minus 3 plus here plus 1 minus 7, it will be minus 6. So the answer will be minus 3 minus 6, answer will be minus 9. Whereas if we take it this way, this way, we will have minus 3 plus 1 in one bracket plus minus 7. So minus 3 plus 1 will be minus 2 plus minus 7. So minus 7 minus 2, the answer will be minus 9. So here a plus b plus c is equal to a plus b plus c. Correct? So we can say that addition of integers is associative. Then let us take some more examples to see this. Another integers that we have is minus 9, 3 and minus 4. So we have minus 9 plus 3 plus minus 4. Now what will this be? Minus 9 plus 3 will be minus 6 plus minus 4. So the answer will be minus 10. Then again minus 9 plus 3 plus minus 4. So here we will have minus 9 plus 3 minus 4. The answer will be minus 1. So minus 9 plus minus minus. So minus 9 minus 1 will be minus 10. So here also this is equal to this. Then let us see the third example. We have minus 6, minus 4 and minus 3. So let us see, we have to make it as a plus b plus c is equal to a plus b plus c. So let us first write these numbers in this format. So first we have minus 6 plus minus 4, close the bracket, plus minus 3. So Then this part we have as minus 6 plus bracket minus 4 plus minus 3. So let us try to solve these two. First here it will be minus 6 plus minus 4. So minus 10 plus minus 3, and the answer will be minus 13. Here we will have minus 6 plus minus 4 plus minus 3. It will be minus 7. So minus 6 minus 7, the answer will be minus 13. So we are getting the same answer. Then again we will consider another 3 integers for our next example. We will take minus 8, 2 and minus 5. So let us try to solve this. We will have first minus 8 plus 2 plus minus 5, and then we will have minus 8 plus 2 plus minus 5. So here what will happen? Minus 8 plus 2 will be minus 6 plus minus 5. Here also it will be minus 6 plus minus 5. So the answer will be minus 11. Then for the next one we have minus 8 plus 2 minus 5. It will be minus 3, and then we'll get the same answer, that is minus 11. So in this case we see that a plus b plus c is equal to a plus b plus c for any 3 integers. Thus we say that addition is associative for integers. So we were learning the associative property. Thus we say that addition is associative for integers. Then next we will see the additive identity. That is the 5th property that we will see is additive identity. So what is this additive identity? Now for whole numbers we know that any whole number a plus 0 is the whole number itself. So a plus 0 will be a, which will be also equal to 0 plus a, that will also be a. So we have for whole numbers a plus 0 is equal to a, which is equal to 0 plus a. Correct? So now let us see if it is true for integers also. Now since this is true for whole numbers, that is the numbers from 0, 1, 2, 3 and so on, so it is also true for all the positive integers, right? All the positive integers. So we say that the whole number 0 is called the additive identity or the additive element for the addition of whole numbers. So therefore we can also say that 0 is the additive identity for positive integers. Because all these positive integers are included in the whole numbers. Now let us see if 0 is the additive identity also for negative integers. So we will see some examples. So the first example is minus 8 plus 0. What this will give us? The answer will be minus 8. Then the second we have 0 plus minus 8. Here also we will get the same answer, that is the integer itself. Then we have minus 23 plus 0. We will get the answer as minus 23 only. Another example that we have is 0 plus minus 59. The answer we will get as minus 59. Then again minus 15 plus 0. We will get the answer as minus 15 only. Another example is minus 61 plus 0. We will get answer as minus 61. So here in all these examples we can see that a plus 0 is equal to a, that is, and for any integer, or in this case for any negative integers, any negative integer a, if we add 0 to it, we will get the answer as the integer itself. Thus we say that the sum of any negative integer and 0 is the negative integer itself. So the sum of any negative integer and 0 is the integer itself. So in the case of integers also, a plus 0 is equal to a, which is equal to 0 plus a. So we say that the integer 0 is additive identity. Identity of integers. So this is all that we will see in this video. In the next video we will learn about the multiplicative properties. Okay, we will learn how the multiplication of two integers and the properties of, see here, the properties of multiplication of integers. So all this we will learn in the next video. Thank you for watching my video. Please like, share and subscribe to the Bodhi Academy.